Kirshen?
Good stuff.
Good. Okay. He's going to be talking about, well, right there, programming across Python workloads. He's been coding for a little while. He told me quoted Python 1.6 or something.
1.5.
1.5. So that's he's been in the game. Knows his stuff. Okay, so let's give him a round of applause for that. 1.5.
Thank you. At the very least, I lie really well. So let me tell you where we're coming at this from. At least on my side, I've done some application work. I've done some ops work. It turns out I really love the ops work. And having been on both sides of the fence, I kind of embraced what we now naturally call DevOps, what people used to call engineering services, what years ago we just called software development. So now we're just going to talk about that as a philosophy and then a little bit of Python underneath. So traditional development, developers write code. Ops deploys code. There's my built-in joke for those of us who got it. I heard at least one laugh. Ops teams hate risk. And the reason is, when something goes into prod, traditionally, not in 2012, it's there forever. The second I plop it on a server, I get hit by a bus, part of the company goes bankrupt, there's only one of these servers. So the key is really that I need that thing to stay living forever. And what you really have is the operational side that thinks, man, devs just throw things over the fence, and they never think about how am I going to survive and let this live for a year, 6 months, a week, however long the change is. And the dev side starts to think, why won't these ops guys just give me another virtual machine? Like, why is it impossible for me to do X, whatever X happens to be? So traditional operations, you know what? Their goal is to support the objective. They need to make it live, make it sit, make it be consistent, make it be reproducible, ensure that things happen the same way over and over and over again. They're very service focused. So if you think about it, that's more reactive than proactive traditionally. Unfortunately, there's frequent manual intervention, not in the greatest ops team, but in reality, servers go down, it's 3 in the morning, I have to go do something about it. At the same time, when you're looking for a developer in the IT world, they're scripters. I mean, Perl came out for a reason. There wasn't large-scale application development with Perl in the beginning. In the mid-90s, you started to see things like the Open Shared Registry system. But Perl was never an application-driving language. They're sysadmins and what I call paranoid futurists. Those are the people who wonder, oh my God, how am I going to let this live for a month? I hit 40,000 exceptions on my server. It's going to fall over. What do I do about it? I have to always be terrified for that universe and that reason. And really, really great ops teams strive for consistency and realize there's absolutely no way it's ever going to be consistent. No one has the same hypervisor. No one has all of the same systems the same way, the same servers the same way. We all pretend. The reality is, I get my budget in June, I spend it in December, and you know what? Whatever I spent in June, it's not the same as I'm getting in December, and I've deployed things along the way. This is the reality of the universe. So enter what we now call DevOps. You're driving operational objectives. You know what that means? It means that I'm proactive. You want to deploy X, I don't really care what X is. But that belief is we need to have that conversation. There's a lot of peace and love that happens there. It's really the hippie approach to programming, if you will. It's managing operations through automation and development. So I'm not doing it once. I'm going to do it 100,000 times. I can't learn through a pattern of 1 because it's not a pattern. But the second we've hit 2 and 3, how do I explore that? How do I scale that? What's the bare minimum that I need to do to make it reproducible? And then how can we increment this and plan for it logically over time? And now I'm an IT developer. That's a new word, but we'll just go with software development who believes in automation, which I'm hoping is the whole room. That means I'm a coder. That means I'm a sysadmin. That means I'm a coach. A lot of the times I walk around talking to people saying, OK, well, when we have 1,000 of this, what happens? At 3 in the morning, what am I going to find in the logs that help me not wake you up? Because I don't want to wake you up at 3 in the morning when the box goes down. And we all know that rebooting the server or restarting the service is not a valid way to troubleshoot a problem. It just means that we've masked it. Yeah, I saw that. You've heard that yesterday, I'm guessing. And you're a paranoid prepared futurist. So that means I need things in the logs. We're going to start approaching having that peace and love conversation. Can you do X? Can I do Y? If I do Y, what can you do to help me feed back and forth? How do I give you access to the logs? How do I give you access to what I'm doing every day? So you'll notice that key difference. You're ensuring consistency through code. It's not that things are identical, but you're going to ensure they're consistent. So how do we collaborate as two traditional sides, if you will? Again, one thing. How can operations formalize and track system change? Because they need to track that change, they need to embrace that change, but they need to understand that change. And it's not always easy to get that understanding. And it's not just code that changes, it's infrastructure. I've got more servers, I've got this type of load balancer, the cloud makes it easier, and that's where we're going to go. How can operations embrace change, proactively support org needs, but also reduce risk? That's their goal. Ultimately, they always want to reduce risk. It's not that they don't want to embrace what we're trying to put out there as developers, it's that the thought starts, the mindset becomes, well, okay, if it's changing on me, I don't want to wake up at 3 a.m. Is this going to cause me to be woken up? What's going to happen? How do I take a vacation? You know, unfortunately, it was December 26th, I think, which for most of you is an off day. For me, it's just like not Hanukkah. And I'm getting a phone call. I'm sitting with my wife on the top of the Empire State Building. And the last thing I wanted to hear is, yeah, you know what? The revision control server is down. What am I going to do on top of the Empire State Building, right? When I'm in New York, when there's just, pardon? You could what? Jump off it? You know, I tried fences, not good. No, they don't work. So, you know, we want to avoid that, right? We like to take vacations. And for developers, here's the key that you all instantly resonate. You need to work in production, right? You're going to deploy on a system that looks like this. It's really hard to work in production because no one in their right mind gives you access to the servers. That would be insane. Instead, how do I give you access to an environment that is 100% identical? Okay, 90% identical. Okay, 10% identical to production. So that's our goal. And really, just how do we get together? How do we love one another? How do we collaborate? Hence the new magical word of DevOps, aka software development. It's developers, it's operations, it's all automated and happy. So it's green. Green's good. In my case, I've got a few clients who I've been doing some work with where this is the problem set, right? We build an internal application a few times now. This is the fourth kick at that can. So that using Django, using libCloud, using Celery, just because it's a vegetable, using Paramiko, and using Puppet, even though that's a Ruby word, we can encourage identically reproduced nodes. So at the end of the day, if you need 100 or you need 4 or it's 6 a.m. and you need an environment called Potato, you should be able to get one, you should be able to drive it up, you should be able to spin it down, you should be able to take care of your own needs. And more importantly, we should be able to plan for that together. We should be able to understand code deployment. And, you know, it's Canadian, so there's maple syrup. So Djangoized components. I'm sorry, I went clip art happy. So where this went, I needed to create nodes in multiple clouds. I chose US West 1 and US West 2, honestly, because everybody chooses US East 1. And if I find one more example that doesn't take into account another Amazon endpoint, it's going to hurt. I used GoGrid because while just about everyone embraces the cloud, and to them the cloud means Amazon, every cloud's actually different. Amazon, fantastically great tools, ridiculously expensive bandwidth. Rackspace, really great bandwidth. GoGrid, unbelievable I/O. There's a difference in the various people you choose to operate with. So it's not unlikely that I'm going to have my web servers in Amazon because I can CloudFront them. But at the same time, any large data processing, probably in GoGrid, because I can have 10 terabyte single-size disks without having to stream together multiple EBS stores. If that makes no sense, I'm sorry. Parallelized workload creation, I'm not going to hit go and wait for 10. I'm going to hit go. 10 are going to come out, and that should be a minute or two, not a 13-minute thing. And configuring everything automatically in Puppet. To me, this is gospel. We can absolutely talk about it offline and what it means, but the reality is Puppet or Chef or shell scripts, it doesn't really matter. I like Puppet. But the idea is that it's reproducible. It's checked into revision control. I can see the changes that happen over time. And more importantly, operations and developers can contribute code to the underlying system. That's where it becomes key. So on the Django side, let's talk about a little bit of lessons learned. How many people hate settings.py? Why do you hate settings.py at random?
Too big.
Too big. Well, that's so unfair. You can't read the slide. You have to say it differently. So, you know, the reality is we talk about separations of concern. In Django, I've got models and I've got tests. And when we do Celery, I've got tasks. You know what I don't have with settings.py? Multiple settings.pys. It's a little bit painful. So the first thing we do, separate that concern out. I can load individual configuration files for every service. And we're going to hit what that is just on the next slide. The idea is for Celery, for, let's pretend there's directory abbot.mq implementation, for Mongo, for anything you're throwing underneath, I like to spin those into separate files that get loaded. Why? Firstly, I can deploy them custom per system if I need to, so that's where it's fascinating. And also because settings.py is just way too big. So this is helpers, and well, you'll get this with the slide. But at the end of the day, you pass in a directory, It sits and it tries to import a Python file because obviously we configure things with Python. At the end of the day, in the settings space, it will go reflect into settings and take every variable in all of these individual files and just pack it into settings. So from anywhere in your Django project, you import settings. Settings imports the helpers. The helpers load all of the configs. And the nice thing that the Ruby world did is actually just have split up configuration files that sit inside of your initializers tree. Now we can do that in Django as well, and for a line or two of code, so it's not bad. Components. This is where we now get into the libCloud side of that world. libCloud's really easy to configure. I need an Amazon key, and I need the Amazon secret key if we're talking about the Amazon side of this. If you're using GoGrid, there's a single authorization key, so the same pattern. How am I going to SSH in? Where's my PEM file? Because I'm going to SSH into things. My Celery settings, different setting for Celery's the broker, which will offload jobs, and the backend collection, which, if you will be used to actually collect results of my jobs. Excuse me. So let's grok what libCloud does. At the end of the day, I need to create a driver for my cloud, multiple clouds. I need to create an image with a size. So I'm saying, go get me this Ubuntu. It needs to be an M1 small, a T1 micro, a yellow transporter. Go create the node, and the key in Celery is the delay. Just go pop it off onto my stack. Let's assume life goes on in the nice, happy, simple case. This is the bare minimum you ever need to do to create nodes in Amazon using Python. You could actually make it smaller if you're one of those people who has massive lines of code that I can't read. But at the end of the day, by default, libCloud gives me US East 1. If you change your provider EC2, that endpoint, you get US West 1, you get GoGrid, so you can hunt in the providers tree, and it all just works the same way. Excuse me. Those node images, you can loop through them with a list nodes, or if you're myself and you're lazy, you can go to the Ubuntu web page and just, what's the latest Ubuntu release? And when you really mess that up and you start using nightlies and you try to figure out why your awesomely automated system can no longer function, you remember never use nightlies. Node sizes, same sort of idea. Amazon has a variety of sizes. I have a library that I use that just sits on top where we query the sizes back from Amazon because I assume they'll change them by adding a medium, as happened in July, I want to say. And then go create the nodes. So libCloud, at the end of the day, also supports direct Puppet integration, if you will, telling it that there's a method to deploy this node. In just a slide, we're going to talk about why that doesn't really work, or didn't work for me, I should say. And then how I get my nodes back, just list my nodes with the driver. So the node pattern, this is what we do, where we is my approach over and over and over again for every node. Once you've got the node spun up, put the public IP in etc public IP. For those of you who use Puppet, you're going to realize that that's a great way for me to understand where this thing is, what cloud is it in, what is it if I start to have to do interesting things. More importantly, if you're on Amazon, you just have no way of knowing what your external IP is from inside of your virtual machine, or your workload, sorry. It's 2012 now. I set the host name, shove it in etc host, ditto with my Puppet master, and you register with your Puppet master. At the end of the day, this node, node A, if you will, talks to the Puppet master, which is a server, if you will, that spits out configurations. A certificate is signed by the Puppet master for said client. And then, poof, the client gets puppetized. It means there's a little guy with some strings and just walking down the street for the glazed people. But in reality, it means that as an operations person or a developer, I can write code that describes my operating system, my workload, the construct behind the system. If I need to touch 100 servers and it's 3 in the morning, clearly we're not touching 100 servers, and we're going to make a mistake if we're doing it by hand. So we can edit some Puppet code, which we don't cover here, slam it into the repo. More importantly, the guy who comes in at 8 a.m. because you've been sleeping all night, you've been awake all night, it's that critical bug. He comes in, can say, git log, that's what happened with my network. Because we all forget to tell people what happened to our network. It's a given. We have ops logs, and we've got all these great ideas like email and IRC. We just don't talk to people. It's 3 in the morning. So you puppetize the client. Poof. Configuration sent out across the network. So Celery, or vegetables. The nice thing is Django Celery, straight up easy integration with Celery. That goes back to the broker slide I showed earlier. You can start your workers. You can have a standalone Celery server. You can pretty much do whatever you need to do. All of your Celeryable tasks, there wasn't a great word for Celeryable, goes inside of your individual Django project as a tasks.py. You wrap any function with the @task decorator, and you're pretty good to go. .delay works, life goes on. You just call your functions over and over and over and over again. They don't always get called, but thankfully I'm not talking about that today. The nice thing is a Celery I, is to keep with the fake motif, is always returned. So I get a result. That result, I can find out, did this thing happen, did it not happen? The most common thing I end up doing is just blocking at the end. I've spun up my 100 nodes. I now need to do what I did last week, which is have a test harness go off, run my tests across all, well, in this case with 4 nodes, and do things. I can only do things when I've blocked, but I need to unblock in order to create things in parallel, hence Celery. And at the end, then I need to block to make sure everything's been created and all of my nodes are nice and identical. So we can just add our results to a list. At the end of the day, when you think everything's been created, iterate through that list. Excuse me. And then parallelization problems, which is what I lightly allude to. For those of you who do or don't know, I don't know how many people have used Fabric. Yes, no? Yeah. Fabric is a global singleton. Man, that screws me. It's great when there's one. It's not great when there's 2. So under the covers, Fabric uses Paramiko, of course. Paramiko is fantastic because it can connect to things. I can SCP with them. There's a nice open source library someone has over the transport layer. And to keep Paramiko running, I can just iterate through the responses, log to debug mode, because I usually don't need these sorts of things. But at the end of the day, it works, and it works really, really well. You should check to make sure your connection is open. That's not bad. The key lesson is logging. It's easy to get around Fabric. But when I'm doing 100 of these, and I'm importing a single Python logger, how am I going to go and actually log things in a way that I can understand what's happened after the fact? And this is where you get down to, I would call this really basic practices. Anytime I'm logging an event, I just prefix the string with the hostname or the IP. Whether it's logging into the machine or all of the Puppet outputs that are in debug mode and using the individual levels that are in the Python logger. If you do that sort of thing, then what you end up seeing naturally is, first of all, you can grep through your logs the old-fashioned way. If you're using something like Logstash, you can match based on all sorts of fantastic regexes. If you're using Splunk, you can now visualize them. None of these are Pythonic, but it all comes back down to the Python logger is actually amazing for parallelization in this way. And what does that give us as ops people? I think this one has an animation. Woohoo. Operations, how do they formalize change? They use revision control, just like devs use revision control. Ops is used to having an ops log. So the idea of having that log be in code, not really a crazy idea. How do they embrace change? They're going to deploy infrastructure through automation. That's what we've done. We spin up our nodes, we tear down our nodes, and the idea is they all happen over and over again the same way. The approach isn't very different to what I'm used to if I'm thinking purely operationally. At the end of the day, it's not unlikely that I'll nesx, create node, blah, 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 blah. Programmatically, I'm doing the same thing. Getting people to embrace the steps may be hard, but getting them to do the Puppet work, relatively easy. How does dev work in production? They simulate the setup with just a different cloud provider. Use a different provider.ec2 blah underneath the covers. So it's nice and it's lazy. And how do we collaborate? We sit together, we write code, ops and devs writes Puppet code, and life goes on. Any questions?
Just step up to the mic if you have a question. Otherwise, well, not otherwise.
Really? I made up words like celeryizable. Come on.
There's a lucky.
Hey. So it was an interesting idea that you mentioned where you split out the settings per module. How do you deal with per environment settings per module?
So the question was, how do I deal with per environment settings per module? So I'm going to make that assumption that we're running Django in multiple environments. I do that all based on host name. And this comes all the way back down to the way Puppet works. But Puppet does really nice matching based on regular expressions. So I'll end up having a series of regexes inside, or a series of regexes, pardon me, a series of settings in a single settings file based on if host name or if the match of the host name. It's the smartest thing I come up with. I'll take anything smarter, to be totally honest.
How do you manage passwords and settings?
How do we manage passwords? Oh, I know, it's a great answer. There's two different answers. The first is, it's earlier on, ops is paranoid, so those password settings files get overlaid your Git commit, or using Git externals where ops and the right people, quote unquote, only have access to the password repo. The rest of the universe has access to everything else. So you load based on paths. More of that to me goes in the Puppet universe where I end up generating these based on my environment.
Okay, thanks a lot.